Okay. Hi everybody. Hope you had a great Christmas and Happy New Year. It's a pity we're not in school, but look, hopefully it's only short term. I think I'll start with your revision work. So your revision work is actually due for today on functions. So hopefully you have it done, which is grand then. If you don't, over the next couple of hours, will you make sure that you have your notes on functions and also the answers to these questions? So you have two things, your notes and your answers. And then they should be in your folders. So just going to Alba's here. So Alba has a folder called Junior Cert Revision. And in there she should have, I won't check it now, but she should have her functions notes done. And she should have her answers to these functions questions completed. That was due for today. So I will be checking that in, I don't know, a couple of hours, maybe 2 hours. And once I've done that, I will take note of who has it done, who does not have it done. I'll send an email to let you know that you're on the list if it's not done. So if you don't receive an email, obviously that means it's done and I'm happy. And then on a Friday, we have to send an email to year heads with work not completed. So it's just going to count as homework not done. Okay? So once I've checked everybody's and I have a list of who's done the work and who hasn't, I will post the answers to the function questions, and I will also put up this week's revision. So this week's revision, we're into week 3, so it's this one here, is financial maths. Okay, so I'll put up the financial maths questions then. Right, so we are doing... Inequalities is the chapter we were working on before Christmas. I actually did get it finished, but I think I only did one compound inequality question, so I just want to do another one or two just to make sure we're kind of fresh and we know what we're doing. And so we'll have a look here at question 6, I think. So question 6 says 2 is less than x plus 1 less than or equal to 5. And then we have this x is an element of natural numbers, which we don't need to worry about for now. We'll talk about it after. So what makes it a compound inequality is the fact that there are 2 inequality signs. And what we do is we use the middle bit twice. Okay, so I've done an example of this up above. So on the left hand side, it's 2 less than x plus 1, and on the right hand side it's x plus 1 less than or equal to 5. Okay, so here this should be the x's side and this should be the number side. So here is a 2 on the x's side, so that's wrong, so I need to get rid of that 2. I do that with a minus 2, and then I balance it with a minus 2. Hop over to the other side then. I have an x here, which is on the number side, so that's wrong. So I need a minus x to get rid of it, and then a minus x over here to balance. And then the last thing I have is a 1, which is a number on the number side, so that's fine. So that leaves me with minus x less than 1 minus 2 is minus 1. There's an invisible number here. There's a 1 missing. And now I need to isolate the x, so to do that I'm going to have to divide by minus 1 to cancel them out, and divide by minus 1 to balance. So the minus 1s are gone, isolating the x. These 2 minuses will make a plus, and then 1 divided by 1 is 1. But because I divided an inequality by a negative number, I need to swap the inequality. Yeah? And just because I'm going to need it, I'm going to translate this. X is greater than 1. Okay? Over on the other side then, I have x's over here and numbers over here. So starting on the left, an x on the x side is fine. The plus 1 is a number on the x side, so no, I need a minus 1 to get rid of that and a minus 1 to balance. And then the last one is jumping over to the numbers side. I have a 5, which is a number on the number side, so that's grand. So that gives me x less than or equal to 4. And again, I've just said it, but we'll write down the translation. x is less than or equal to 4. Okay, and up here in the question, in each case, graph the solution on a number line. So x is greater than 1. That means 1 is the smallest, so it will go on the left. And x is less than or equal to 4, so that means 4 is the biggest, so that will go on the right. Okay, so I end up with, just get rid of this, for goodness sake. There we go, I lost my whole line. So, there's my line. I have 1. Okay. I have 1 on the left, 2, 3, and then 4 on the right. Okay, so going back to 1, you ask yourself, is 1 a possible answer? It doesn't have the or equal to here. Okay, so it's not an answer, which means I give it a circle. Is 2 greater than 1 and less than 4? Yes, it is. Is 3 greater than 1 and less than 4? Yes, it is. Now, 4 itself, is it a possible answer? It is, because if you look here, it does have the or equal to. Okay, and then the last thing we need to do is go back and look here. It's natural numbers, and natural numbers are positive whole numbers, which means there's no need to shade in. All I need is the dots. All right, so that's my compound inequality put on a line. Now, I've seen this come up quite a bit on the papers. This is a compound inequality. It's just asked a little differently, so I just wanted to go through this. So in part A, they give us the set A. These here are chain brackets, which are curly brackets that we use in sets. And they give us an inequality. Now, they also have this little bit at the start, right? See this bit here? So all that bit tells you is that the variable in this inequality is x, okay? Which we can see if we look at the inequality. But it's not part of the inequality, okay? It's just a little bit of notation. And we can ignore it because we can tell that x is the variable in the inequality just by looking at the inequality and seeing the x, okay? All right, so they want us to take this inequality, which is the A inequality, and they want us to list the elements of A and graph them on a number line, okay? And again, we will note that, yeah, we'll come back to that, okay? So over here we have our x side, and over here we have our number side. Starting on the left, we have 2x, which is an x on an x side, so it's grand. Minus 1 is a number on the x side, so that needs to go. Plus 1 to get rid of it, plus 1 over here. Hop over to the number side, and we have a 9, which is a number on the number side, so it can stay. So that's 2x less than or equal to 10. Isolate the x by dividing by 2. Divide by 2 to balance. So the x, 10 divided by 2 is 5. And since we divided by a positive number, we can leave the inequality. Okay, so they want us to list the elements of the set and graph it on a number line. Okay, so I suppose it's the same thing, we'll just graph it. So let's throw this down. Okay, so we'll translate. X is less than or equal to 5. So that means 5 is the biggest, so I'm going to put that over here. And then we go down, less than 4, 3, 2, 1, 0, minus 1, minus 2, minus 3. So go back to the one in the question, which is the 5. Is 5 a possible answer? Yes, it is, because we have the or equal to, so 5 is a possible answer. Is 4 less than 5? It is. Is 3? Is 2? Yes, it is. And 1 is less than 5. Now, 1 is always kind of a bit of a pivot point, because if this was a natural number set, it wouldn't go any lower than 1. Okay, so we'll just go back quickly and check. And remembering that it says integer set, and integers are positive or negative whole numbers. So we can keep going into the negatives. So 0, minus 1, minus 2, minus 3, and so on. Integers are positive or negative whole numbers, so we won't shade. Okay, and that's part A. Part B. Again, we have the chain brackets. This time the set's called B. We have the chain brackets here and here. Once again, they tell us that x is the element or the variable in the set, so we can ignore that, and we take down the inequality itself, which is 1 minus 2x less than 3. And again, we take note of the fact that it's integers again. All right, so x is on this side, numbers on this side. The 1 is a number on an x side, so we minus 1's cancel, minus 1 to balance. The minus 2x is an x on an x side, so leave it alone. Hop over to the other side, and the 3 is a number on the number side, so leave it alone. So that gives us minus 2x less than 2. We want to isolate the x, so we're going to divide by minus 2 to cancel it, and divide by minus 2 to balance. The x is fine. This is a positive 2 and a negative 2, so different signs give me a minus, and 2 divided by 2 is 1. And because I divided an inequality by a negative number, I need to swap the inequality. We'll translate it. X is greater than minus 1. So if x is going to be, I don't know if I got that I did. If x is going to be no, we were doing so well. Try it again. Stop. Okay. So if x is going to be greater than minus 1, that means minus 1 is the smallest. So minus 1, and we're going bigger. So 0, 1, 2, 3, 4, 5, 6. So back to the minus 1, is it a possible answer? It's not, because again, I can't remember which one's small. We're missing the or equal to part. So that's going to get a circle. 0 is greater than minus 1, so is 1, so is 2. 3 is greater than minus 1, so on, and so are all the other ones. Okay, and again, it's integers, so no need to shade in. Okay, so C. C says list the elements of A. Now, don't know, do you remember this symbol? That's the symbol for intersection in sets. Okay, so what they want us to do is take the two inequalities that we've just figured out, and they want us to intersect them. This is how it becomes a compound inequality. Okay, because now we're taking two inequalities and we're going to look at them together. Okay, so if I look at the two translations, what we have is a number that's greater than minus 1 and less than 5, not including minus 1. Okay, so you're talking about 0, 1, 2, 3, 4, and 5, because it was including 5. Yeah? So greater than minus 1 and less than or equal to 5 would be these numbers. And then the last part is to graph it on a number line. So the two things I'm graphing are x is that greater than? Yeah, x is greater than minus 1 and x is less than or equal to 5. And I'm going to graph them together on a number line. So, okay, so if we're talking about greater than minus 1, that means minus 1 is the smallest, so that goes over here. And then we go 0, 1, 2, 3, 4, and because of this, we're going to stop at 5. Go to this side, and is minus 1 included? No, it's not, because there's no or equal to, so I give it a circle. Over to this side, is 5 included? Yes, it is, because I have the or equal to, so that gets a dot. And then we dot everything in between. And because this question was all based around integers, integers are whole numbers, so we wouldn't shade anything in. Okay, so that is a compound inequality question, just kind of wrapped up, not to look like one, I suppose. Yeah, so hopefully that makes sense. For homework, I would like you to do these three, 8, 10, and 13. All compound inequalities, nice and, straightforward in terms of, I mean, they're tough, but they're straightforward in terms of same as my examples. So the bit in the middle gets used twice. You use it with the minus 7 and you use it with the 2. Okay, so will you try those three, please? And as I said, the answers to those need to go into the homework folder on your OneNote. Okay, that is how you are submitting your homework. That homework is due for 9 a.m. on Wednesday morning. Okay, that's when you'll receive your video for Wednesday's work. So by 9 a.m. on Wednesday morning, this homework needs to be uploaded and in your folder. Is that okay? All right, best luck with that. Oh, I should have said, sorry. If you have any questions about any of the content or the homework or anything, what I'm going to use is the collaboration space. So see here. So in the collaboration space, I have a folder called Compound Inequalities, which is based on this class. So if you're listening to me going on and there's something you don't understand, will you go in here and type in a question, please? And then over the course of the day, I'll go back in and I'll have a look and I'll answer any questions that is in the collaboration space, okay? So just if you have any questions, do that. Is that okay?